Hey, what's up, players? It's time for another video in our series called Pop, 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 Another Server Drop. Now, in this particular one, not really going to be popping a machine, but we're going to be using CTF techniques and learning different CTF techniques that we can use in future popping. And this one here is off of the Try Hack Me website. It's called CTF Collection Volume 1. And it just has a variety of different challenges that it asks you. Real quick and simple, compact little deals. About 21 questions. And they have everything to range from different things like cryptography to strings program to all kinds of different things that will aid you and help you whenever you decide you want to go ahead and pop another machine in later ones for CTF. So yeah, let's get cracking on this bad boy. And let's move on down here. So you can see there's quite a few challenges, and I've already finished it, so you'll see the answers here, but that's not relevant. That's not really a big concern here. We just want to go over the techniques used. If you're not familiar with my Pop, Pop, Pop series, essentially I take CTFs, and which are capture the flag. They're kind of war game type of scenarios. And I teach basic hacking concepts using these type of challenges. And I differ a little bit than some normal playthroughs or walkthroughs of different CTFs, because a lot of those ones will assume you know a lot of different things, and those kind of like run through popping the machine. They won't explain a ton of things. Now, there are exceptions to that. John Hammond's got a good channel where he goes into pretty good detail as well. But for the most part, I'm going to try to break down as simple as I can the different concepts that you'll see here, so you're not going to turn into what they call a skitty and just basically copying and pasting whatever I give you and saying just roll with it and don't even know what you're doing. We don't play that here. We want to make sure we know the methodology, why we're doing it, why we're using certain switches with commands, you know, those sort of things. Now, there's multiple ways to do some of these different techniques that you're going to see today, but for the most part, we're just going to stick with some stuff that I use on a normal basis, and you can just curve it to whatever you want for yours. All right, so let's get to the first question here. And it says here, what does the base say? Can you decode the following? So when you look at this here, this is a cryptography question. Whenever you see these double equals here at the end of a string, it's likely that it's a base 64 string. And they use that as a pattern technique for, you know, the length of the cipher in this case here. So there's multiple ways that you can decode base 64, but we're going to take a real simple way so I can teach you a little bit of terminal as well along the way. So if we look at our terminal here, what we're going to do is we're going to run the echo command. And what the echo command allows me to do is to say, whatever I'm going to put in these quotations here, I want you to echo onto the screen in front of me. So if we were to go ahead and say echo, and then we'll copy this here and paste it there. If I were to hit enter, it will echo it here on the screen like that. We don't want that. We actually want to pass it to another command. So what I'm going to do is hit my up arrow to replay the command. This time we're going to use something they call a pipe symbol. And what that means is it says, take the output from the first command, which is the echo one here, and use it as input for the next command that I'm about to do. So the next command we're going to do is called base 64. That's a one that's already in Windows here. And we're going to use the tac D. When I say tac, I mean dash. And that means decode. So we're saying echo this phrase, use it as input to do a base 64 decode. Okay, so hit enter. And bada bing, bada boom, pop, pop, pop. There's our first flag. Okay, so this is what the flag will look like if you're doing these sort of capture the flags. Okay, so yeah, that's the first challenge there. Little base 64 business. Pretty cool stuff. All right, let's go to the next one. So this one involves downloading a task file. So let's go ahead and do that. And I've made a directory, and for some reason, they don't actually label it with a name. So I'm just going to call it whatever the title is here, which is meta. So I've made a directory under Try Hack Me CTF collection. And what I'm going to do is I'm going to call it, I'll just call it meta, meta.jpg. Okay, and we'll save that. Did I save that as a JPEG? I think I did. Let's check. No, I did not. Okay, so let's try that again. I forgot the extension there on that, so we'll save that. We'll make sure we have a dot at the end of it there. So we'll say dot JPEG in our collection. Boom. All right. So this one says meta, 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 and then it's got a bunch of dots. I'm hungry, I need the flag. All right. Well, it's a JPEG, so we can do a couple different things. One, we can just open it up and see what the skinny is with it. or we can actually go ahead and just use something they call Exif Tool. So if we go over here, I have installed Exif Tool, and if you don't have it installed, you can do install or apt install Exif Tool like that, okay? But I already have it installed, so I'm gonna say Exif Tool, and if you do attack H, it's always good to find out what you're actually typing in for any of these things, but it doesn't have a very large help file in this particular case, apparently, or attack H is being used for something else. So what I'm going to do is just go ahead and just exif to, doggone it, I'm not typing very good today. And we'll say meta.jpg, and we'll see if there's any metadata inside of this file that we can use, and pop, pop, pop. There we go. There's our next flag. So when you actually use this Exif tool, you're able to go ahead and do a variety of different things with metadata that's in the file. There's other ones that you can use when it's a little bit more involved, maybe with a password protected one or something. You can use something like steghide or something to that effect. And we'll use those here today as well. But that's an example of one. And I think, let me see if I know what the help file is. Maybe it's tech help. Nope, okay. But you can always man it. Man is a manual page in Linux where you can actually look at a manual of whatever the tool is that you're looking for. And you can start going down through just by using your down arrow here. And it will give you some description here of some different switches and commands and all that kind of stuff that you can use with it, and other options right here. Okay, so it's always good to look at that so that you don't turn into some skitty and you actually know the ins and outs of the tools that you're using instead of just kind of running stuff you see on YouTube. All right, let's go to the next one. You can tell I don't like skitty action. All right, let's go down to the download task file for this one. What's this one here? Say mon, are we going to be okay? I'll just say mon.jpg. Sounds good. All right. So mon.jpg, save it in here. Something is hiding, that's all you need to know. Interesting. So if something is hiding, it's likely, maybe it's a steg file, like a steganography. Steganography is hiding something in a picture, in a particular file. It is sad, feed me the flag. All right, so what we can do is we can go ahead and use steghide. Now, I suck at typing, so I actually have my trusty little Dratus project, and I have all my commands already pre-done on here, so I can just copy and paste for these and not have to worry about any type of mistypes or anything like that. So for this one, we're going to actually use steghide to see if there's something hidden within that file, and then extract it if we can. Hopefully it's not password protected because we don't have a password. So the command line would be steghide, and then you would use the word extract because that's what we want to do, extract something from here. And the TAC SF is standard for saying it's a steg file. Now, just to verify that, you go steghide, and you would say TAC help, or you can use the man page in this case here. And you'll see right here where it says TAC SF means select a steg file. Okay, so that's what we're going to do. We'll go back and copy and paste this. It's not the right, oh yeah, it is. Mon, okay, we'll use that. So we're going to pop on over here, and our file we called mon.jpg, so we'll use the steghide on this. It's asking for a passphrase. We don't have one, so let's hit enter. It extracted it either way. So it looks like we didn't need a passphrase. It looks like it extracted something called final message.txt. So in Linux, if you want to go ahead and read a file within the terminal, you can use a command called cat. So we'll say cat, and then we'll paste in the file. And you can see right there is our flag. Pop, 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 pop. Love and life. All right. So that's the next challenge there. All right, let's continue on. All right, this one here says, where is the flag? So in this case here, it just says magic. I don't even know what that means, but in this case, there's no file to download, so we don't really know what's going on. So your best bet is to use view source. Now, another thing you can do as well is if you're looking at this saying, where is the flag and there's no file, there's a possibility that it's as a hidden field maybe, and that if you just kind of highlight like that, see, you'll see it. Now, what we can do just to verify, we can go ahead and highlight the field, and we can right click and go inspect element. And we do that in developer tools here. If we start expanding the paragraph that it's in, and we expand this, there it is right there. Okay, so this one right there is our flag. So we could have done it either way, but that's kind of showing you that it's not in a file, so they just want to use a little trickery there. All right, so that one's knocked out. Next one, QRRR. I guess we can kind of decide what this one is. It's probably a QR code of some sort. So let's download that, and we'll save it, and we'll just call it qr.png, it looks like. So we'll say qr.png. Now we can use the, I'm trying to remember the applications that we have here. I think it's called something with an R. We can actually view the file itself if we want to see what it is and verify that it's an actual QR code. And I think it's a graphic right here. Ristretto image viewer. I'll keep this up because we're going to have to view a few files. All right, let's go back here and let's pop on over here to our TryHackMe and CTF collection. There it is, QR. All right, we can see it is a QR code. So what we can do is go to a QR decoder page. And I just happen to have my links here. So we'll open that there. So you can go to any type of online QR code detector, or decoder, I'm sorry. Bring it up, and let's go ahead and grab that file. And we'll upload it. And we'll see what it comes up with. And right there's the flag. Pop, 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 pop. Another one down. All right. We are tearing things up. Loving it. All right, next one, reverse or read it. All right, let's download the file, see what it says. .hello. Interesting. All right, let's save this, and we'll just call it reverse.hello. Oops, I actually typed that in wrong. Let me do that again. Typed it in twice, so reverse.hello. And let's go take a look here. Now, a tool you can use to find out what a particular file is aptly called file. So you can use the word file and then the name of the file to find out exactly what it is. So we'll say file reverse.hello. All right, it tells me it is an executable of some sort. So by the name reverse in the title, I can assume that they want us to kind of reverse engineer an executable. Now, an easy way to do something like this is you can use something called strings. And what that will do is it will pull out all the string values in an executable. Okay, so it's not complete reverse engineering, but it is opening up and looking at the inside of the executable file, and it's saying anything that are words or characters, strings, display them here, and we'll take a look at it. Our guess is the flag is somewhere in that mix. So we'll say strings and then the name of the file, in this case reverse.hello. All right, so we've got a lot of different strings here. We're looking for THM, obviously. And what we could have done to make things easier is we could have piped it to a thing called grep, and that would have been able to find that particular one, but I just want to show you what the output looks like, so we're not going to do that today. There you go, right there. There's the flag. All right, now this is a good way to find like passwords that are hard-coded in an application, those sort of things. So strings is a great program to use to be able to find that stuff out. All right, pop, 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 another one down. Let's go ahead and tear some more up here. All right, some more decoding. Can you decode it? Okay, well, they don't really give us too much here to go on. Now, there are hints that are over here on the right. Now, when it gets to be as ambiguous, is that the word? When it gets to be as not as obvious, in this case here, what type of cipher we're dealing with, use a hint, I guess. We'll go ahead and click on the hint, see what they say. Base 58. So I guess what we could have done is we could have highlighted it and Google searched it as well. Let's see what comes up with that. And look at that, base 58 decode text. So it looks like that's the best way to go ahead and do it, is do a Google search for it if you didn't want to do all the hints on that. All right, so let's go ahead and copy that. And we will pop it in here and we'll decode it as base 58. Now before we had done a base 64, so this is just another different iteration. And there's our flag, pop, pop, pop. Loving it. Great, let's close out that. All right, we're doing pretty good, man, cranking along. Left, right, rot 13 is to mainstream solve this. So left, right, they're talking about transposition ciphers where they shift things around, or they may say, take the A and then go, skip 3 characters and then the next letter is that and so on and so forth. And they had something they had called a Caesar cipher back in the day that used rot 13. Think of it like if you take the alphabet, right? There's 26 letters in the alphabet. Let's say you took that and split it in half. So you had what, A through M maybe? I don't know. Let's just pretend it is A through M on one side and N through Z on the other. I don't know if that's accurate, but I think that's the split. What you could then say is A is actually N, right? Then the next one, B, is actually, go down through the alphabet that way. That's similar in concept to what they're talking about with a rot 13. We're taking it and splitting it and rotating it or whatever. But this time it's telling us that rot 13 is not actually the one that we would use. So if we go to rot13.com, you can actually run something through a variety of different rotation types. And I think that's probably our best bet because we don't really know which one it is without looking at the hint. So we'll go ahead and grab this. And by the way, this is one of the very basic ciphers from way back where they had it on I think it was on a scroll or something back in the reason they call it Caesar cipher. I think back then, if I'm not mistaken, I could be, but I think they had it on a scroll, and as you unrolled it, a certain way, you would be able to decode the letters based off of how the scroll was written or something to that effect. But I could be off base. Who knows? So I'm going to pop that in there. Let's start off with rot 1. See what happens. Okay, looks like nothing really legible there. So let's do rot 2. Nothing there. We're looking for THM, of course. What our flag looks like. Okay, nothing there. 4, nothing there. Oops, I skipped one, didn't I? 5, nothing there. 6, nothing there. Ah, there we go. 7. So rot 7, THM, hail to Caesar. Pop, pop, pop. Another one down. Very cool. All right, make a comment. I'm guessing this is another one where you view source and it will be actually in the comments itself. So no downloadable file, no ciphered or encoded text. So what I would do in this case here is I would highlight whatever that is and I would inspect the element for that area of code. And if you see here, it's kind of hard to see. Let me see if I can bump that up a bit. So right here, you can see in the comment, or it's not actually, it doesn't even look like a comment there, but in the hidden field, as it were, it was lightly colored, as you can see right there. There's our flag. Okay, so that's the awesomeness of doing view source. And you'll do that quite a bit throughout your web application hacking stuff. All right, can you fix it? I accidentally messed up with this PNG file. Can you help me fix it? All right, let's download the file, see what's going on. So we'll call this one fix.png. All right, let's see what we got here. Let's use our, did we already close our Rosetta tool? I think we did. So let's bring that back up. I think it was called Rosetta, no. Was it RE something? RE something, file viewer. Oh man, let's see. Okay, enough of this. Let's just go look at all applications and we'll look under R. And this time remind me to keep it up. All right, let's see. Here we go. Ristretto image viewer. Let's go ahead and see what's going on. It says it needs to be fixed, so let's see. Okay, so I don't really see anything wrong with it per se, but apparently there's something wrong with it. So let's take a look here. We can actually look at the hex of it using something called XXD, which is on Linux, and we can view kind of what's going on there. So let's let me grab the command for that. So in this case here, XXD, again, will allow us to look into a hex file, or view the hex of a particular file, which would be the hex that we're looking for here. And the head portion is saying, just give me the very first part of this file. And I'll explain why in just a second. So we're going to go ahead and copy this over here. And obviously we're going to change the name to fix.png. And it's only going to give us the very first portion of the file itself. So why we did this is because of something they call magic numbers. So in a file, like an image file, you have a certain identifier for that image. So in other words, whenever you try to upload a file, let's say you upload a GIF to a web page and they don't allow GIF. The way that they're checking it sometimes is they look at the first 8 bits, right? I'm sorry, the first 8 characters here of your hex to see if it has what they call a magic number that identifies that particular file. In the case of GIF, it's something called a GIF 89A, right? PNG has a different one. So if you look at a website that has the magic numbers right here. So for instance, if you're looking at a JPEG, your magic numbers are going to be these right here. If you're looking at a GIF, it's going to be these 4 blocks right there, okay? Now, the one we're messing with is a PNG, I think, right? Let's see. Let's verify here. Yes, PNG. So we're looking at a PNG, and we can see here PNG graphic file. And we see 8950 4E47. That should be the first 8 characters of this file, but we can see it's not. So when they say it's broken, that's what they mean, okay? So we saw a picture of a world in our image viewer, and I think I closed it, didn't I? I keep saying I wasn't going to do it. But we saw a picture of a world in that one, but we're going to have to change it here to fix this. Now, what we can do is we can use a tool called Hexedit to be able to go ahead and do that. So let's go ahead, type in Hexedit, and I think it's just Hexedit. I don't think there's really any switches that are needed to put us into edit mode. Awesome. So we're now in hex edit mode of this particular file. Now we actually have to change the first 4 characters that we see here on this, and we're going to have to do it with the numbers that we saw here, 8950 4E. So we'll say 8950. I got a short-term memory. That's not very good. So we'll say 80. No, I'm sorry, 89. And the 54E. And I think it was 47. Is that right? Yep, 47. So that's what a PNG should start with. And as you can see, when we did that, it actually added this right here. Because if you look up, after we go out of Hexedit, take a look at what we originally had. It was not this. Okay, so we'll do a Control X, and then a Y to save our changes. So right here you can see it did not start with PNG. So it wasn't recognized as a PNG file in that particular case. So we just fixed this particular one. So if we do XXD again on it, fix.png, we can now see PNG, not this, right? It's because we actually modified our first 8 bits of what they call a magic number, okay? So in this particular case, if we were to go ahead and, man, I tell you what, I'm getting tired of opening this thing here. I got to remember, I got real short-term memory with this sort of thing. So if we actually look at the file now, and we say fix PNG, we can see, oh, look at that. Now it's no longer a picture of a world like we originally had. Now it's the actual flag. How awesome is that? All right, very cool. So I just minimized that, and there we go. So that was a little bit more involved than the other ones, but yeah, it was fun. Taught you a little something about what they call magic numbers. Now, keep in mind, too, this is handy whenever you're trying to bypass a file upload. I've done this at my workplace where my workplace asked me to do an application test on a file upload application, web application that they had. And they were filtering and they were doing whitelist, so they were doing good where they were blocking everything I was trying to put in there. But I did come across one where I had changed the payload of a file where it was a PDF, but I actually put a PHP reverse shell code in there, and it did allow that one through. That's because they were only checking the first 3 or 4 bytes, I think, for their filter. So I actually had done it further down in the header, about 9 or 10 bits in. So I basically told them, listen, you need to filter a little bit longer on the head to make sure that they're not really trying to screw with that or anything. But the magic numbers are what are important when you're actually looking at these particular files. So, all right, very cool. That was a good one. Read it. Some hidden flag inside the Try Hack Me social account. Okay, so in this particular case, we don't know what social account, so we're just going to hit the hint. Okay, Reddit. So, yeah, sure. Let's go ahead and Google. Oh, let's see here. We'll say Try Hack Me Rooms Reddit, maybe? Okay, let's see. Let's try that. Oh, there it is. Booyah! So right down here, we can see there's the flag. All right, so just simple Google search on that one. Really nothing too crazy. All right, excellent. Spin my head. Okay, so this, some may think I've never seen this before. I don't even know what this is. Now, I try to run a clean channel because I prefer to stay clean and not use any bad words. But in this particular case, unfortunately, we have to use one here for this binary F tool. So I've never heard of this language before doing this particular challenge, but that's the one they give me, is that. So I guess that's what we'll go ahead and look for, right? So we'll say that, word, and decoder. And yeah, there it is. So let's grab it and let's see what happens here. Oh, let's see here. Interpreter, binary code to interpret. Okay, so it looks like we put it in there, maybe. Let's see. Let's grab the nonsense here. This is crazy. Why would anybody write in this language? All right, so let's get rid of this nonsense here. Paste that in there and execute. And over here on the right, or left, I'm sorry. Okay, it's not really giving me anything there. Let's see here. Let's try a different page. Is this a different page? Let's see. Nope, same page. Huh, interesting. So I wonder if it's maybe just adding in extra spaces somewhere, maybe. Let's see. Let's be very careful about what we highlight. And I guess try it again. See what happens. There it is. Second time's the charm. So I guess you got to do it twice. I don't really know what the deal is with that, but either way, that's the way hacking goes, right? So there's the flag right there. And yeah, let's get out of that one. So that one's kind of a strange one for sure. All right, let's move on. Exclusive strings for everyone. Interesting. So I'm guessing S1 means string 1. S2 probably means string 2. So let's see if we can get a hint without using the hint down here. Let's do a search in Google for exclusive strings. Let's say exclusive strings cryptography. Looks like it's pulling up some sort of band name or something. XOR, okay, XOR. So it looks like they want us to XOR this particular one here. So let's say XOR online. Let's see if we can find a online XOR. All right, so first input, second input. So the way XOR is going to work in this case here, it's going to take two different strings and it's going to XOR them. It's typically what you'll use. It was used actually back in the early days of Wi-Fi with WEP, where they are actually trying to make a, I think the process of when they had before they started adding in the weak initialization vectors. I think this was part of the process of the actual encode and decode of a packet or an authorization packet for WEP, and that's where it was found to be pretty weak, because anybody can XOR 4 numbers together or however many and calculate it. So in this case, let's go grab our 2 strings. String 1, we'll pop that in there. And then string 2. There we go. Let's calculate our XOR. And it gives us to us in hexadecimal format. So that's not the string. So let's do a hex decode. Try that. And let's grab this, pop this over here. There it is. So what we had to do in that case is we had to XOR 2 strings together. It gave us a hexadecimal output according to that website there. So I went ahead then and went to a hexadecimal decoder, popped it in, and we can see pop, pop, pop. We have our flag. That was a cool one. All right, let's move on. Binary walk. I can already tell by the name here they're talking about a tool called Binwalk. Binwalk will let me look inside a file. Sometimes you'll get a file that's JPEG, but in actuality it's a compressed zip file. So to find out if it is a compressed zip file, for instance, you would use Binwalk on the file. So we'll go ahead and download whatever file they're saying. So we'll say save file, and it's a JPEG, and we'll say Binwalk, because I believe that's the tool we're going to use here. .jpeg, and I got real bad fat finger here today. All right, so let's go pop in over here, and let's do Binwalk. And we'll say tacky for extract, and what was the name of the file? We said binwalk.jpg, right? And indeed, it is a zip file. Look at that right there. Very cool. So in this particular case here, uncompressed size, you got a file called hello there.txt, and that's what we're going to be trying to extract in this particular case here. And I'm trying to remember what tool or what switch will do that for us here. I think it's just, is it just the word extract? There it is. So, did it extract? Did it not extract it? Let's take a look here. Oh, there it is. I'm sorry. So it extracts it, obviously, and puts it in this folder here. I thought I had done that. So, so when you use Binwalk and you extract it, it looks like it puts it into a separate folder. There it is. Okay, cool. So the tacky, again, is to extract the zip file from within the file itself using Binwalk. So in this case here, let's tack that, and there we go. There's our flag. Pop, pop, pop. All right, pretty cool. That's a great tool to use, man. If you come across a lot of CTFs and it's a JPEG file or a GIF file, but in actuality it may be a compressed zip file, that's a good tool to use to grab it. All right, darkness. There is something lurking in the dark. All right, let's download the file. And we will call this, whoops. Okay, so it's black. We can see that. So let's download the task file. We'll call it dark.png. And we already saw that it's just a black picture. So I suppose we could try Exif Tool on it. See if there's any metadata. It's a PNG, right? File not found. Oops, I'm in the wrong directory. I'm going to CD up back to my normal directory. Oh, let's see what we have here. We have nothing of use for us. Okay. Interesting. So in this particular case, what we could use is another tool that has to do with steganography, because it's likely to do with steganography. Now, if you take a look at the hint, it will tell you, try stegsolve. Interesting. So what you can do is you can actually go ahead and use apt install to first, or wget, I'm sorry, to grab that particular file. So in this case, what we're using is the word wget in Linux. And we're pulling down this particular file, and the jar file tells us it's a Java file. And in this case here, the output name we're giving it is stegsolve.jar. Now, in order to run it, execute it, in other words, we're going to give it executable privileges by using something called Chmod, which allows me to give privileges to something. With the X in this case, it's saying give an executable bit to this particular one to be able to run it as an executable. And this one, I just kind of stuff it into a folder and mess with it there. Okay, so yeah, so stegsolve, that's what we're going to do. So let's grab that first, and we'll copy that and download it there, and then we'll give chmod to it. We won't move it to another folder. We'll just use this particular one we're in. So we'll say chmod +x stegsolve.jar. Excellent. And then from there, I think we just run stegsolve, if I can get it right here, solve.jar. We may have to do a / in the front of it. Okay. So in this case, to run the executable, we'll have to do a / like that. It should bring up a tiny little tool. Look at that little thing, little bitty thing. And let's go ahead and open up the file that we had. What was it called? Dark PNG, right? Okay, I've never really messed around too much with this tool. I see down here we have some right and left arrows. And up here it says normal image. So if we click on the right arrow, okay, so it's doing inversion colors on it. Let's keep doing that. Alpha plane, nothing there, nothing there. Let's go down through some of these colors here they're using. Okay, so a red plane now. Looks like it's still hidden. Excuse me. Green plane. Oh, there it is. All right, so I guess as you just keep going down through all the different color mix-ups that they do with it here, with the RGB, it's putting it through those different analysis engines for that, and it's able to extract that from it. That's pretty cool. I like that. So there's your flag right there, and yeah. Pop, pop, pop. Another one dropped. Let's go back here. All right. Got that one knocked out. A soundin' QR. Interesting. All right. Let's download this one. It's called Soundin'. So looks like it's a QR code. Okay. Looks very similar to what we did last time. So let's save this one here. We'll just call it sound dot, shoot, what was it? A PNG? I can't remember. I think it was. Let's verify. Yep. All right, so we got a sound PNG. Let's go ahead and go to that same one we did before where we had an online QR decoder. Let's browse for that and upload it. Let's see what we get. Ah, interesting. SoundCloud. So what is this? An audio steganography, it sounds like. Let's copy that on over. And let's go to here. Interesting.
The flag is SOUNDINGQR.
Okay, it said if you didn't hear that, it said this. Close out of that. It said the sound is. Then it gave a variety of different numbers. It took me a little bit to do that the first time. I had to listen to it over and over again because they were really pretty fast. But it's basically sound in QR. But that's pretty cool. Had a little file that you can download. I don't know if you could hear that on the video or not, but that was a pretty cool one right there. All right, dig up the past. Sometimes we need a machine to dig up the past. The hint is machine and dig the past. In this case here, there's a tool or website, I'm sorry, called the Wayback Machine, archive.org. And what it does is it has archived billions of different websites at different points in time. So if I wanted to view, I don't know, Microsoft back, Microsoft.com back in, 1980 or whatever, what you would do is you would just go to the Wayback Machine and you would put in, let's say for instance, Microsoft.com. We'll just use them as an example. And then it will tell you how many, how far back it goes. It looks like we go at, we can go farther than that, I think. Oh yeah, all the way back there. Let's take 1999, right? So if we click 1999, we can see what the Microsoft web page looked like back in 1999. So we'll just pick, I don't know, February 8th. We're just picking randomly here. And we'll look at a snapshot of it. Pretty crazy how they've archived all of these websites. And you can back and look at them. The use of it in hacking techniques is if they had contacts or sensitive information on their page initially because they weren't security conscious when they designed the web page, and then later they became security conscious and they changed the web page to remove those names and contacts and things like that. We could always go back and look at an older version of that website. So look at that. Wayback Machine. This is all the way back in the old days here. Let's see. They got games. What kind of games they had back then? It's running kind of slow on this. Let's see here. What was this again? 1999? Yeah. Let's see what Microsoft, the official Microsoft Game Store had back in that day. Probably something like Flight Simulator or something like that on a 15-inch floppy. Look at this. Yep, right there. Flight Simulator 2000. So anyways, pretty cool site to be able to do that sort of thing. So I'm guessing in this case, our targeted website is this, and our date is January 2nd, 2020. Okay, so let's go ahead and pop that in our Wayback Machine here. Come on. And let's go ahead and take a look at that specific date. Did it not do it? Let's try it again. All right, and it said January something, 2nd, 2020. So here's 2020. Let's click that. And January 2nd. Here's a snapshot. Let's take a look at it. It's pretty cool how they go through this right here to get this together. Let's see. THM flag, maybe, right here. Let's take a look at that. Not there. Let's scroll down a little further here. Oh, there it is right there. Booyah! That's pretty cool. So yeah, that's using the Wayback Machine. Another great concept in cybersecurity. Pretty good stuff. Uncrackable. What is this all about? Can you solve the following? By the way, I lost the key. Sorry. So let's try again like we did last time to search for this and see if something comes up on Google. Looks like it's all CTF collection try hack me ones. Okay, so it must be something pretty interesting. Let's take a look at the hint on this one. Viginia, I don't know how you say that, but let's grab that. So what we're going to do is we're going to use a tool called CyberChef. I love this site here. You essentially are able to do all kinds of different cool crypto on this. Let's go ahead and put our input in right here. We'll paste it. Oh, I'm sorry, the wrong one. Search. Paste it. All right, so we want to do a Viginia decode. So what you do is you drag that out into this recipe area here. And the key, we don't know because it says it lost the key. But let's go ahead and put this in the input at least. And let's see what happens. So put this in our input. No key entered, so we have to figure out the key. Let's see here. All right, so here's something interesting. All along, we've been seeing THM, right? See that right there? We keep seeing that, but this time we're seeing something different. We're seeing full cap, try hack me. Let's try that. Pop that in as a key. All right, so we're getting somewhere. So what is this? THM, THM, THM. Okay, that's interesting. Let's try that. So obviously that's not the right key, so let's try that. There you go. Try hack me. You found the key. So this is a great tool here for doing everything that we were doing, like base 64 decodes, hex to decimal, all kinds of cool stuff. CyberChef should definitely be in your bookmarks for using crypto. It's pretty cool stuff. All right, 2 more to go. Small bases. Decode the following text. Let's see if we get anything here by searching Google. And again, it looks like it's just try hack me. Oh, let's see here. Decrypt file. We don't want to do that stuff. We don't want no freeware. So yeah, let's see here. Small bases. I'm going to assume it has to do again with maybe base 64, maybe. I'm not sure. Let's take a look at the hint. Decimal to hex, hex to ASCII. Well, that's pretty straightforward. So yeah, let's go ahead and do a decimal to hex converter. And let's grab the file, pop it in there. All right, and then the next one was hex to ASCII. All right, so let's grab all that. And we want to go hex to ASCII. Paste that in and convert, and there is our flag. Sweet. Very cool, very cool. All right, our last one, read the packet. Let's download this bad boy. Ooh, we got a PCAP file, so we're going to be using Wireshark. PCAP file is some output that you would get if you were using a network sniffer like Wireshark to be able to read the contents of the actual traffic. So in this one here, I'm going to call it wire dot, shoot, what was the extension? PCAP PNG file, right? PCAP NG. I think that's right. Yep. All right, so what we can do is, let's go back here, and I'm going to use Wireshark. Wireshark is a tool that will allow me to go ahead and view network traffic, capture it, sniff on the line, see if there's anything coming through. If it's using, you know, like Telnet or Instant Message or something like that, and it's unencrypted, I can view it within Wireshark. It's pretty cool. So we'll go ahead and do wire PCAP, and what I'll do is an ampersand, and what that means in this case here is it's going to open it up in its own process, so I can still use the command prompt while bringing up the actual application. All right, so this is Wireshark, pretty cool stuff. It's got quite a bit of stuff in here. So we're looking for some interesting things. Let's see what they're looking for specifically. I just hacked my neighbor's Wi-Fi and tried to capture some packets. He must be up to no good. Help me find it. Well, that's not very enlightening. Let's see here. So we got quite a bit of data. So if you look at these, I'm going to go down to, let's see if there's a SYNAC packet. Now you can speed things up by doing filters up here on the top, or you can click up here and type in different things. I'm not so much worried about that right now. I'm going to speed things up a little bit on this and go down to around the line number. But I want to show you what its main use is for, or what a good use is for this sort of thing. So when you actually do something called a three-way handshake, what it means is you're using what's called TCP. So if I went ahead and I had computer A and I want to communicate with computer B, computer A will send a packet called a SYN packet. This is if we're using TCP. And then that computer B, if it's up and running and it's accepting connections, it will then send back another packet called a SYN-ACK, where it acknowledges, and it starts incrementing different sequence numbers to determine what order the packets are, because there's going to be a multiple amount of people querying that particular server at the same time. So it has specific sequence numbers. I don't have them, you know, the math behind it currently, but right here is one of the sequence numbers. And then the final thing of what it would do is an ACK, right? So I would send, computer A would send an ACK to say, I have got your SYN-ACK, and I acknowledge that. We have now opened up a socket to me and computer B to be able to communicate and send packets back and forth and visit the website and do whatever. So that is what they call a three-way handshake. Wireshark is great for viewing that, right? So if I click send down here, you'll see you can expand this, and it will go to transmission control protocol, and you can see like the sequence numbers are listed there, and the destination port and the source port. And down below, you can see some different options, and you can see the flags that are being actually set, which is right there, the send flag. So all kinds of different cool things. I would definitely use Wireshark and learn how to use it properly, okay? In this particular case, though, another thing you can do real quick is you can right-click on a send packet, and you can go down to where it says follow TCP stream, and it will basically go and outline the entire connection process that happened for that particular one. Now, you can't really make heads or tails of it in this case, but there are some cases where you can actually view what the attacker has been doing. You can see its commands if they're using like some unencrypted technology to be able to do it, like an FTP or something like that. So it's a great tool to be able to do that. Now, up here, it's kind of stopping me because it actually inputted a filter when I did that. So I'm going to clear out that filter. So to speed things up, I'm going to go directly to the line that I had found this at, which was 1827. So let's scroll down to that bad boy, just so we can see exactly what's going on. All right, so 1827, and right around this area here. So we can start to see, and this is what you would normally do in this particular exercise, is you have to scroll through and just find something that stands out, something that's odd. In this case, I see a get flag. Okay, pretty cool. Let's go ahead and right click and follow, and we can say follow HTTP stream. And then from there, we can kind of see what it was doing. So it did a get of the flag, then the server responded, and it gave him the flag right there. Pretty cool, right? So that's an example of how you would use Wireshark to be able to decipher this particular one here. So yeah, all in all, pretty awesome stuff. I really liked the questions that were given, the tasks that were here. It covered a lot of different topics that you would normally see in a CTF. Things like the encoding and the base64 and the tools like steghide and Exif tools and Binwalk and strings. All stuff we're going to use in a lot of our pop series, and you may have already seen it in some of the other videos. So now it kind of gives you an idea of it. So this is a great one to try on your own. Is go ahead and boot this one up here and tear into it. So the next video we'll definitely be doing something where we actually do a box and tear it up. I haven't decided which one we'll do next. We'll do something interesting, and then further down the line as well, I'm going to do an introductory course to the Burp Suite tool to aid in the Bounty Hunter training video series that I have as well. So make sure you check it out at YouTube, and you also check out at my website, shikataganai.com, and it has all the different video series that we're doing here and the different topics. The two main ones that I have is the Pop into the Server Drop series, and then we also have Bounty Hunter training, which is to train you in some web application security tips to help you with bug bounties. That one is not as fully fleshed out yet, but there's a variety of different documents for it. So, until next time, keep on popping, baby. Peace out, players.